FastMCP 3 implements server-level transforms as a pipeline pattern, where component names and behaviors flow through a sequence of pure functions before reaching clients. This design enables systematic modification of tools, prompts, resources, and templates without altering their original implementations. We will examine how a namespace transform prefixes component identifiers, observing its application through the addTransform method and the resulting name modifications. The setup involves creating a server instance, registering a tool, and applying the transform to demonstrate name conflict prevention. From FastMCP, import FastMCP. From FastMCP server transforms, import namespace. MCP equals FastMCP server. At MCP, tool. Def greetname, SDR. Return hello name. Hash namespace all components. MCP, add transform namespace API. Hash tool is now, API greet. This code demonstrates server-level transforms in FastMCP 3, specifically using the namespace transform to modify component names and prevent naming conflicts. The pattern shows how transforms act as filters in the component pipeline, modifying names as they flow from providers to clients. Here, the namespace API transform prefixes the greet tool with API, resulting in API greet being exposed to clients. The approach is particularly useful when composing multiple servers where naming collisions might occur. By applying the transform at the server level with addTransform, all components from all providers get the prefix, ensuring consistent naming across the entire server. This is more flexible than provider-level transforms, which only affect components from specific providers. The trade-off here is between explicit naming control and potential verbosity. While namespacing prevents conflicts, it adds prefix overhead to all component names. The alternative would be manual naming, which becomes error-prone as systems scale. The namespace transform provides a clean, declarative solution that maintains consistency while allowing servers to be composed without name clashes. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, making it available for creating MCP server instances. From FastMCP server transforms, import namespace. Imports the namespace class from the FastMCP server transforms module, which provides functionality for prefixing component names to prevent naming conflicts when composing multiple servers. MCP equals FastMCP server. Creates a FastMCP instance with the server identifier server. This instance will be stored in the variable MCP and serves as the main server object for handling Model Context Protocol MCP communications. The string server acts solely as a label for identification in protocol handshakes, visible to clients when they connect. At MCP, tool. Def greetname, SDR. Defines a function named greet that takes a string parameter name and returns a string, decorated with @MCP, tool to register it as an MCP tool. The decorator automatically uses the function name as the tool name, the docstring if present as the description, and generates an input schema from the type annotations. Return hello name. Returns a formatted string that embeds the value of the name variable into the greeting hello name. This uses an f-string to interpolate the variable directly into the string literal, producing output like hello Alice, when name is Alice. MCP, add transform namespace API. Adds a namespace transform to the MCP instance that prefixes all component names with API to prevent naming conflicts when composing multiple servers. Tools and prompts will receive an underscore-separated prefix, e.g., API toolname, while resources and templates will get a path segment prefix in their URIs, e.g., /API/resource. FastMCP3's server-level transforms implement a pipeline pattern where pure functions systematically modify component names before they reach clients. The namespace transform exemplifies this by prefixing all component identifiers, like tools, prompts, resources, and templates, with a specified string, such as API. This prevents naming conflicts when composing multiple servers, as demonstrated by the greet tool being renamed to API greet after applying namespace API. The key insight here is the declarative nature of this approach. By adding the transform at the server level with add transform, you ensure consistent naming across all components from all providers, avoiding the error-prone manual naming that becomes unmanageable at scale. The trade-off is the added verbosity of prefixed names, but this is a small price for the flexibility and reliability gained when composing complex systems. The pipeline pattern ensures that transforms act as filters, modifying components as they flow from providers to clients, maintaining purity and predictability in the process.
The namespace erases greet and scribbles API greet in its place, as if renaming were magic.